A team of nautical designers and engineers have set themselves an extraordinary challenge: to build a fleet of cruise ships larger than anything ever seen before. The Oasis class of ships dwarfs its predecessors. And in a shipyard in France, the third of the group is almost complete. When launched, the Harmony of the Seas will become the biggest passenger ship of all time.
You can definitely call this ship a small city. It can house almost 9,000 passengers and crew on board. It's a fully self-sufficient island, if you will.
But these ships' dozens of restaurants, theatres, bars and attractions would all be impossible without one vital component, buried deep within their interior.
The engines are the heart of the ship, and the electrical network is the veins to provide the power forward to the ship. Without the engine, the ship is not alive.
So how do you create an engine powerful enough to move a floating city across the oceans and provide enough electrical juice to keep more than 6,000 passengers and over 2,000 crew comfortable and entertained? It's a problem that would have been unachievable without one of history's great innovators. The HC Ørsted in Denmark might be a monster, but the power of each Oasis-class ship is 6 times greater. The huge vessels use 6 Wärtsilä diesel engines, the largest of which is almost 13 meters long and weighing well over 200 tons. Fitting them is an engineering feat in its own right. Now, 2 years into this trailblazing project, what was once an impossible dream is finally becoming a reality for engineer Timo Ijuri-Javori.
We are now on the main engine room of the ship, and we are going to test diesel number 1. So this baby here. This is one of the most exciting days of the project. Yo, Ivo, let's start her up.
The giant engines generate electricity that not only powers the motors that drives the 227,000-ton ship across the world's oceans, but also provides enough energy for the floating city above.
It feels great to see the engine alive. In total we have 6 engines, and the total output of the ships is 93 megawatts. That equals to a power of 1,200 road cars.
Without this mighty powerhouse, the world's largest cruise liners would be an impossible dream.
Starting of the main engine is one of the main milestones on the shipbuilding project.
In a shipyard in France, the third of the largest class of cruise ships ever built is nearing completion. When launched, the Harmony of the Seas will be a record breaker in its own right.
It is 361 meters long, 47 meters wide on the waterline. We have over 2,700 passenger staterooms, and we can have almost 9,000 people on board at any given time. Largest cruise ship in the world, pretty impressive.
The enormous scale and width of the vessels has allowed them to do something never before attempted on cruise ships. The Oasis class has a split superstructure, which allows open space through the middle of the ships.
Now we are on deck 8, forward, facing backwards. We are on the Central Park area, one of my favorite places of the whole ship. The inside cabins are not anymore inside cabins, but we have a perfect view to the park. We will have solid pavement here, live planters, just like a normal park. This concept is totally unique. You cannot find it anywhere else. Only in Oasis class has V-split superstructure.
Its upper structure may be impressive, but for the ship to be a viable design, it will also have to deliver beneath the waves.
So there are a few factors that are very important for the fuel efficiency of the ship. And clearly the biggest one is the hull shape. The hull shape needs to be extremely well designed so that you have a good hydrodynamic shape.
So how do you engineer a streamlined shape to efficiently power this gigantic ship through the world's oceans? Engineers of the OASIS class ships used huge 10-meter-long models in a tow tank that simulated a variety of sea and weather conditions. The result? A super-efficient bulbous bow design that has been further enhanced by a cutting-edge system known as air lubrication.
The air lubrication technology requires microbubbles, so we push the air through the bottom of the ship through a specifically designed grid that creates the microbubbles. We have them in a few locations on the ship in the forward part, and as the ship moves forward, the cushion of air moves along the ship's hull.
The velocity and size of these microbubbles orientates the airstream along the underside of the vessel. The resulting cushioning effect significantly reduces friction and the power needed to propel the ship, increasing energy efficiency by around 5%. This colossal class of cruise ship may be streamlined under the surface, but above water, their sheer stature poses a huge challenge.
As we have such a big wind profile on the ship, it's almost like driving a skyscraper at the seas. We have to be able to control her to the direct position what we want to have to be.
In order to drive the largest cruise ships in the world through the water, the propellers on the OASIS-class vessels are on a predictably grand scale. Each of the 3 bronze screws is 6 meters wide and weighs 40 tons. But creating a 21st century megaship also requires new challenges that need cutting-edge propulsion solutions.
The ports we sail into are sometimes fairly small, so we want to be sure that we can always maneuver the ship in a very safe way. So we're not dependent on tugs. We can independently maneuver the ship into the ports we want to sail into. We have to really park it on a dime.
The solution lies with an invention developed in the 1950s by German engineer Joseph Becker, who devised a way of doing without a traditional ship's rudder. Instead, he designed something called the rudder propeller, a propeller that could turn through 360 degrees and so steer the ship as well as propel it. The modern incarnation of Becker's concept is what enables the world's largest cruise ships to achieve the seemingly impossible: the podded propulsion system.
We have 3 ASI-pods, each of them are 20 megawatts in size. And 20 megawatts you could translate to being about 200 family cars. It's a huge amount of power, but considering the size of the ship, it's what we need.
The 3 pods actually act like airplane propellers, pulling the ship through the water, rather than traditional pushing-style ship propellers. Combined with 4 times 5,500 kilowatt bow thrusters, they allow the cruise ship's captains unparalleled control. Dials on the bridge allow the pods to be turned to the desired position in an instant and maneuver the vessels into locations that would have once been impossible.
Well, the ASI-pods came as a result of really thinking outside of the box. It's ingenious.
The biggest cruise ship on the planet is just 4 months away from completion and launch. The Harmony of the Seas is the latest in a class of ships that eclipses anything that has gone before. Sitting as tall as Tower Bridge, as long as 5 jumbo jets, and as wide as a football pitch. For the project director, Petteri Keiso, it's a dream job.
When I really look at her, I'm amazed always, every single time by the size of the ship. It's big, but it's beautiful, it's awesome.
This mind-boggling structure will hold up to 6,000 guests, making customer satisfaction the #1 priority. A potential challenge when the weather doesn't cooperate.
The clearest issue we have is that the ship is not stationary. It moves, it rolls, it heaves, there's all kinds of movements and acceleration on the ship, which makes it a little bit more complicated.
So how do you keep such an immense vessel steady, so customers and crew can experience a smooth ride, whatever the sea throws at them? The Oasis-class vessels take the magic of the gyroscope into the 21st century. Instead of the giant spinning wheels employed in the USS Henderson, Harmony of the Seas and her sister ships use a small gyroscope as a sensor, which, via computer, controls mechanical stabilizers.
So in rough seas, what we can use to minimize the roll and the movements of the ship are stabilizer fins. And they are actually fins that emerge laterally from the ship's hull. This is the location we are in now. And what it does, it's sort of like a wing that comes out of the ship. It emerges laterally like this, and then it turns around its axis.
A 20-meter squared stabilizer blade is recessed into each side of the vessel amidships. They're deployed as and when the state of the seas demands it.
Stabilizer mostly counteracts the roll, so the sideways movement of the ship. So if the gyroscopes feel that the ship starts moving this way, it asks the fin to exert force so that it counteracts the movement here, so it tries to always right the ship.
It's now more than a century since the first purpose-built cruise ship set sail on the world's oceans. Now, by drawing from the originators of the past.
Standing next to this 3-4-story tall engine is very impressive.
Adapting their ideas, honing them, and making trailblazing innovations of their own. The engineers, designers, and workers constructing the Oasis-class cruise ships are making history.
When first these plans were thought of, I'm sure there were a lot of people who thought that we were absolutely nuts. Absolutely crazy to think of even building a ship this large. But you know, we are not afraid to think large, think big, think outside of the box. And that's what you need. You need a little bit crazy thinking at times to really make great things.
They've succeeded in making the impossible possible.
When we started this project more than 2 years ago, we had only design on the paper. But as we now see it, the dream come true, I feel really proud of what we have achieved.